Hey guys, it's often said that good features are what make or break models' performance. As we know, machines do not understand characters, that is categorical data. They do not understand characters, right? Then how do we work with categorical data? Which should make sense to us and also to a machine so that it understands that characters and help us create the predictive model. We are on part 4, feature engineering in machine learning for categorical data. As I've said, machines do not understand characters, that is categorical data. Then how do I convert that categorical data so machines can also understand and improve models' performance? This is called categorical encoding. So the process of converting categorical data into integer format. Machines understand numbers, they do not understand characters. And converting that categorical data to numbers is what categorical encoding stands for. We have started a new series, a playlist of videos to understand everything about feature engineering. We have already seen data cleaning and imputation techniques in the last video. Now we're going to talk about feature extraction, specifically what is categorical encoding. So if you are new here, I'm a mentor in the field of AI and machine learning. Started my journey long back 12 years before as a mentor, and during this time I got exposed to multiple technologies from Java to DevOps to Python to data science and now also AI. I have been helping corporates understand and implement applications, especially in Python, data science and obviously AI. In this video, we will deep dive and understand how to perform categorical encoding, and there are different types, one-hot encoding and ordinal encoding, and to know and understand how encoding impact on machine learning models. And most importantly, we are going to see the demo example, the hands-on on the same how to perform categorical encoding. You watch this video till the end and let's get started. Hey guys, welcome to AI with AI. This side Asif Imnad. First, let's understand different categorical encoding techniques and what their types are and what each type means here. So as you see in the diagram, we have mainly 3 types in categorical encoding. As you see, first one is the one-hot encoding. This is also called nominal encoding. Then the second type is ordinal or label encoding. And the third type that we have is count or frequency encoding. What does this each type means? When I say one-hot encoding, what it means? I'll just put the definition for now, and in the next slide you will understand what it actually means. So one-hot encoding is nothing but converting characters to a Boolean variables. Converting character to 0 or 1, where idea is just to indicate if category is present for each observation or no, right? Character, convert it to 0 or 1s, binaries, and check if present or not. That is one-hot encoding, or also called nominal encoding. Then the second type, ordinal or label encoding, stands for where you put numbers but not only binaries, you put sequences 0 to n, that is 0, 1, 2, 3, 4 till n, where n is nothing but the distinct categories of the variables, and these numbers are assigned randomly. There is no sequencing as such, but we provide a number, a count, not only binaries 0 and 1s, right? Unlike one-hot encoding. And count and frequency encoding, where you put some logic as well, where each categories are replaced by the count or the percentage of observations that show that category in the dataset. Basically, if certain observations come multiple times, then we need a count, or we need to know the percentage full dataset, then we can use frequency, right? So these are the 3 different basic types that we have in categorical encoding. Let's understand with the example so that it will make more sense to you. So this is the image that I found on the Google, and definitely not created by me. I have also given the credits here, dailydoseofds.com. So why to waste time, right? So if something is very well explained and already created, so I have taken the reference of this image. If you see here, one-hot encoding, we converted these rows into columns, green, red, black, orange, right? And wherever that specific category is available, we are encoding 1, and if not available, then 0. So green is available here, 1, others 0. Same goes for red, 0, 1, 0, 0. Same goes for black, and same goes for orange. And there are some improvisations for one-hot encoding, which is also called K-1 or drop one feature encoding, right? Dummy encoding, which we are also going to see in the demo using pandas. Here, if you see drop one feature, that is K-1. K is number of features, right? 4 features. K-1 is 3. So we considered only 3 now. But if you observe, it is not green. If it is not red, if it is not black, then definitely it is orange. So why do you need 4 columns, right? So that's why K-1. Then we have one more type, which is effect encoding, where let's say if none of the value represents any this color, then that's -1. Let's see one by one in detail. I'll jump to the next slide. So one hot encoding, as I've explained, I have data which something looks like this, number of 4 rows, and I have replaced it as columns. And you see wherever green is available, replace it with 1. If green is not available, replace that category to 0. Binary values. That is one hot encoding. Boolean values, right? 0, 1, 0, 0. For red, we have red available, but for other columns, red is not available. This is one hot encoding. Very simple to understand. Then as I've said, we have k-1, which is one drop feature encoding, right? We'll see that in the demo. Let's understand the other type, which is label encoding. A label encoding is nothing but where you provide a unique labels, some random numbers. So I don't want 0 or 1s. I want numbers to each type. Let's say I want to represent green as 1, red as 2, black as 3. Right? So you see wherever we have green, we see number 1, red 2, black 3, and green again, it's not 4, it's 1, right? So we are representing each type with unique labels. So this is called label encoding. Very simple to understand. Then what is ordinal encoding? We also have something called ordinal encoding. What is ordinal encoding? Ordinal, name itself says order, data with certain orders. Here, these are not colors, but these are data with some orders, right? These are the sizes. So extra small is the first one, small second, then medium is third, and the large is fourth, right? So I want to number these values accordingly, which will make the sense as well. So extra small, you see 1, small 2, medium 3, and large 4. This is how we are encoding these values, and this is called ordinal encoding. Simple, easy. Yes, I know. Then what is count encoding? We have one more type of encoding, which is count encoding. Now I don't want the label. Now I don't want the sequence or the order, but I want to count how many times this small came, how many times that green color came, right? So if you go to count encoding, you see that it represents the count of each type. So there is green, we see green 2 times, right? So in the encoding technique, it will put 2. Now these are not random numbers, these are not sequence, but it is count of each type, right? So green came 2 times, that's why I see encoding is happening based on the frequency. Then red 1, black 1. Okay, so out of 4 data sets, only for green feature we have 2. This is count encoding. Simple, right? I hope you understood the different types of encoding techniques which we have seen. So going back to this diagram again now, so that you can connect the dots and understand the different types of encoding techniques, right? One hot encoding, ordinal, and count or frequency encoding. So these are the 3 different types we understood. Now let's jump to the demo part and let's see how we can implement the same using pandas and Jupyter Notebook. Okay, before we proceed and discuss in detail, if you are new here, don't forget to hit that subscribe button and the bell icon so that you won't miss our latest videos on AI. We see you are watching our videos, but 90% are not yet subscribed. We put a lot of efforts creating these videos for you free. Keep us motivated by liking and subscribing, so YouTube algorithm will also help us reach more audience. So, did you subscribe and like? Thank you. Let's come back to our original discussions. Okay, so this is the same demo which I have uploaded on the GitHub repository. You can find the link in the description below. Whatever implementations, demos I'm showing here, these are the same demos which are already uploaded to Git repository. So you can find that out in the description below and in the pinned comment as well. Okay, so we are on the feature engineering part, which is 0. I'll go to feature engineering and we already seen 3 demos, right? All of this you can ignore for now, and only one folder is important for us currently, which is data. This is where I have kept my data, house price and housing data, then Titanic. We are going to use Titanic dataset and housing price dataset for our demos. And here we are on part 4, which is categorical encoding. So I'll open this Jupyter Notebook. Okay, now let's see the demo. A one hot encoding using pandas. We are encoding into k-1 dummy variables. So it makes sense, right? I don't want to consider all the variables in one hot encoding, which we already discussed, right? I want to drop one feature, which is also called dummy encoding or k-1 encoding. K is number of features. So we have total 4 features, -1 is 3. So we are considering only 3 features here. Why 3 features? Why not 4? Because if it is not green, red and black, then it is definitely orange. So that's why dummy encoding, k-1 encoding. Let's see the same. I'm going to import pandas and model selection for splitting our data into train and test. So train, test, split. We did the import part. we're gonna use only certain columns, and Titanic dataset I'm gonna use here, right? So these are the columns I'm gonna use. Let's read the CSV file which we kept here under data, Titanic dataset.csv, data.head. Let's execute. So this is how the data look like. So do you see that we have categorical data here, right? Machine understand 111 passenger class survived 110, right? But machine doesn't understand sex is female, male. So these are categorical, these are characters. It doesn't understand that. Similarly for cabin you also have categories, for embarked we also have categories, right? So we need to replace these values with certain numbers. That is categorical encoding in simple words. And let's see how do we do that. Let me execute this cell as well. Here what we are doing is under cabin you see multiple strings, right? I just want the first letter and I'm printing it again. So you see cabin B, C, 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 right? So I removed unnecessary data and taking only the first letter here. Cool. Proceeding ahead, and very important in encoding, we need to split our data into training and testing, right? Though this is feature engineering, we should do that because these methods will learn patterns from the training data, and that's why we want to avoid leaking information and overfitting. So very important, divide our data into xtrain, xtest, ytrain, ytest. I don't want to consider the y column which is survived. Basically this is our predictor. In the Titanic dataset we know that, right? By looking at the data we need to identify if passenger survived or passenger didn't survive, right? But I don't want to consider that. That's why we removed this. This is our target, and test size is 0.3. That means testing data is 30% and training data is 70%. Random state 0, randomly select the sequence, and let's print the data how it looks like. So if you look at the shape of the xtrain and xtest, this is how the split looks like. 916 rows, 6 columns for training data, 393 rows and 6 columns for test data. Let's explore the cardinality to understand how many labels it has. So I'm looking for sex and using a unique function here which will show me how many different types we have under sex. So if you see under sex we have male and female. Very simple. Same for embarked, I'm gonna see the different types. In embarked we have 1, 2, 3, 4 types, also some question marks, right? And in cabin we have 8 labels and also missing data. So if you observe, it will also help you identify the missing data, right? So 8 types in the cabin. Why I'm doing this? Because this will help me know whether do you want to go for one hot encoding, whether you want to go for count or ordinal, what type of encoding you want to do. This is what you can decide by looking at the cardinality. So let's start with the basic one, that is one hot encoding. So once I understand the data, now I want to do the encoding for very first column, which is sex, right? And I'm gonna do that by using a very simple method in pandas, which is getDummies. So getDummies is a simple method which will help you convert your categorical data into binaries, and basically it is doing encoding for us. And let's see how it looks like. Do you see this? By simply pandas.getDummies and printing my temporary dataset, this is how it looks like. So this sex column above, if you see, this sex column is converted into the different cardinality features. So you see 2 different columns created, and wherever you have for passenger number 501, let's say if these passengers are female, you see 111, and this passenger is not female, so you see 0 here. So this is simple one hot encoding, 0 or 1. Very easy. We did a very simple method, getDummies. Now let's do the visualization better. Let's put it in the data set, and to do that I'm gonna do the concat in the original data set. So you see for column sex, concatenate this with whatever encoding that you did using getDummies, and let's print it by using .head. Okay, just in front of this you can see the concatenation happened, and now I can do the same thing for other columns like embark and also for the cabin. Very simple. Again, getDummies, I want to convert this categorical data into numbers, 0 or 1s. You see that this is happening for different types, and also I am gonna concatenate it for easy visualization. Let's do the same for cabin using getDummies, and it will convert those rows into features, and also it will do the encoding, converted those values into 0s and 1s. And I can also do this for all the variables together. getDummies will automatically recognize variable types, object and categorical type, ignoring numerical variables. So you don't have to actually do it manually one by one the way we did it, right? So manually I'm taking one feature at a time, one column at a time, okay? But we don't really need to do that. You can put getDummies for all the data, okay? It will automatically identify which features are of categorical type, and it will encode that. Okay, let's print and execute this. So you see 916 complete data set, and automatically it converted sex female and sex male into one hot encoding, and automatically encoding happened for sex female, sex male. For passenger class, if you see, it is already in numbers. It is not touching these variables, these columns, right? And if you see for cabins, again different features created. So getDummies is automatically taking care of encoding wherever there is categorical data. Okay, let's do the same for the test data set. And this is what I see, nothing different data set, right? So training, these many 916 rows, 18 columns and 393, and now I see only 16 columns. Why do you see a less number of columns for the test data set? This is because maybe there are chances that a type which we have chosen here, cabin A, B, C, the one of the type may not be available in the test data. So you see we have cabin T type which is available in train data, but this is not available in test data. So these are some of the limitations of getDummies. Doesn't really matter. Now let's do for k-1. As I've said, why do you want to consider all the features? I can do this for k-1. Alright, so here I just need to do drop first true. Nothing different. Same function getDummies for which column? Sex column, drop first. Let's print this. Do you see this? Why do you need male and female two different columns? If I only have male, I can easily identify that means the passenger 501 is female, right? So for male it is 0. If male is 0, then the passenger number 501 is female. Yeah, so that's why k-1 or drop one feature encoding helps you reduce number of columns. It's a better way on top of one-hot encoding. Okay, same thing you can do for embarked. Rather than 4, now we have only 3. Same thing I can do for the training dataset. For complete dataset, I'm just doing getDummies for full data and drop first. This is k-1. Now if I'm doing k-1 for complete dataset, now this time I have 15 features. Without k-1, how many features I had on train dataset? Without k-1, I had 18. So do you see? Number of features are reduced. So that's why k-1 hot encoding is a better approach. This will reduce the information burden, right? And the processing power. Simple. Let's do the same for the test dataset. For complete test dataset, drop first true, pd.getDummies, nothing different. Let's execute this. Okay, for test dataset, we see 16 features without k-1, and when I do k-1 getDummies on the test data set, k-1 drop first, you see 13, right? So 2 features are reduced. Amazing. This is a very simple demo that we have seen to perform one hot encoding and one drop feature k-1 encoding. Hope you loved it. Alright, so in this video we have discussed feature engineering for machine learning, how to perform categorical encoding, and what are the different ways to categorical encoding and implement the same using pandas. We still encourage you to do some more experiments with the feature engineering to see how it can improve the performance of your machine learning model, right? So I have uploaded these demos on our GitHub repository already. You can find the link in the description and also in the pinned comment below. Alright, and that's how we come to an end of this video. If you have any questions regarding the same, let us know in the comment below. If you found this video helpful, please subscribe to my channel and hit the like button. And don't forget to share this video with your friends and the colleagues. Thanks for watching. See you again next time. Till then, take care and bye-bye.